So I just showed you the example sheet number 8. Good morning, everybody, by the way. So please, could you try to do question 1? Question 1 on sheet 8. Hopefully you can see what I'm seeing here. Okay, so please try and see if you can do question 1. Okay, if you have any questions, you can write on the chat room. There's a chat room for Zoom. So any questions you have, please write on in the chat room. Okay. Or you can also talk to me. You can. If you just joined, we are doing question 1. Question 1 on sheet 8.
Okay.
Oh, you good? Okay. Guys, you okay? Hello. You all right? Okay. Let me now show you how to. If you haven't done it already, I assume some of you have already done it. So let me show you how to do question one. All right. Now this is question. Oh man, what am I doing? Okay, this is question one. Question one in sheet number 8. Okay. So basically, you have the question says you have three three data points IID IID normal with geometry, right? Can you guys hear me? Okay. And you have two estimators for mu. The first one is this is the first estimator, and the second estimator is this is the second estimator, all right? And the first part is to find the bias. Find the bias of the two estimators, or biases rather. So find the biases of the two estimators, right? So that's what I'm going to do, the first thing. So let me start with the first estimator, which is mu1 hat. So this is by definition is the expectation of mu1 hat minus mu, right? So this becomes the expectation of minus mu, right? And take the expectation inside, you get this, right? And we know that each variable has mean equal to mu. So this is a third of mu plus mu plus mu. All right, so this is clearly equal to 0. So what this implies is that that mu1 hat is an unbiased estimator for mu. Okay. And similarly, you do the same thing for mu2 hat. All right, so you get bias of mu2 hat equal to the expectation of mu2 hat, right? So this would be 1/4. Oh, sorry, the expectation of x1 plus 2x2 plus x3 divided by 4 minus mu. Yeah. And taking the expectation inside, you get a quarter of the expectation of x1, 2 times the expectation of x2, plus the expectation of x3. Right. Okay. So this becomes quarter of mu plus 2 mu plus mu minus mu. Okay. So this would be, this is once again equal to 0. Right. So the conclusion is that mu2 hat is also an unbiased estimator of mu. All right, so that's part 1. Now part 2 of the question is asking you to find the variance. So part 2 of question 1 is to find the variance of the 2 estimators, right? By the way, there's no need for you to copy this. I'm actually, at the moment, I'm actually recording this session. So after the later today, I will upload the video, and also I will also upload the copy of my written notes. Okay. So you should be able to see. Okay, guys. So there's no need for you to copy anything down at the moment. So, okay, guys. I hope all of you are doing well, in spite of all the problems we have. If you have any question, just, if you have a mic in front of you, just talk to me, okay? To find the variance, okay, we start with the variance of mu1 hat. right, which is this. And so if you take the 3 outside, it becomes 9. Then in brackets, you have variance of x1 plus the variance of x2 plus the variance of x3. Right? So this becomes 1/9 times sigma squared plus sigma squared plus sigma squared. Okay. So this is equal to sigma squared divided by 3. So the variance of the first estimator is sigma squared divided by 3. And okay, now let's try to find the variance of the second estimator, which is the variance of this, right? And so if you take the 4 outside, it becomes a 16. So in brackets, you have variance of x1 plus 4 times the variance of x2 plus the variance of x3. So this is gonna be a 16th of sigma squared plus 4 sigma squared plus sigma squared. Okay, guys. So this will be 3 sigma squared divided by 8. All right. So the variance of the second estimator is 3 sigma squared by 8. Okay. So that's part 2. Now part 3. Part 3 of question 1 is asking you for find is to find the sampling distributions of mu1 hat and mu2. Now you may remember when I talked about the normal distribution a while ago, one of the results I mentioned is that the linear combination of IID normal variables or linear combination of independent normal variables is also normal. So if you look at mu1 hat, which is, excuse me, sorry, this is mu1 hat, okay? All right, so which is clearly a linear combination of independent normal variables. So it must have a normal distribution with the mean, which we have already computed to be mu, and the variance is, we already computed, is sigma squared by 3. All right, this is because of what I taught some time ago in the lectures, that a linear combination of independent independent normal variables is also normal variable. Okay. And similarly for mu2 hat, you have this, right? Which is once again a linear combination of independent normal variables. So it's normal with parameters this and this, right? Okay, so we are done. We are done question 1. So do you have any questions on my solution? You can, yes, no?
No.
Okay, good. Right, so can you try question 2, please? I'll give you a few minutes. Can you try? Okay, let me show you question 2. So let me stop this share. So if I go to question 2, let's see where it is. Share. Okay, here we are. Okay, you can see it now. Okay, this is question number 2 on sheet 8. Okay. I'll give you like a few minutes and see if you can do it. Guys, you okay?
Yeah.
You're doing question 2, right? So let
Yep.
me. Okay, so let me show you if you haven't done it yet. So okay, so question 2. Question 2 is this, all right? You have x1 to xn. Sorry, you have a random. Sorry, you have a random sample. X bar 1 is x bar 1 is the mean of a random sample of size n1 from a normal population with mean mu and variance sigma squared. So from what I taught you in class, guys, I hope you remember what I taught you earlier. X1 must have right? It must have this distribution, all right, from what I taught you. Okay. And also similarly, x bar 2 is a mean of a sample of size n2 from a normal population. So it must have this distribution. So this is, I mean, if you want to know where these actually come from, if you look at my notes on the normal distribution, you will see where they come from. Okay. All right. Now, what you're given is an estimator for mu, which is a times x bar 1 and 1 minus a times x bar 2. Okay. This is an estimator for mu, right? And the first thing you are asked to do is to find the bias. Of this estimator. So let's try to do that. So the bias of this is the expectation of the expectation of mu hat minus mu, right? Which is the expectation of a x bar 1 minus a x bar 2 minus mu. Okay. Now, if you take the expectation inside, you get a times the expectation of x bar 1 plus 1 minus a times the expectation of x bar 2 minus mu. Okay, guys, so now we know from what I just wrote down above that the expectation of x bar 1 is mu, and the expectation of x bar 2 is also mu. So, so this is what you have. So this is clearly equal to 0, right? So this implies that, so what we have shown so far is that mu hat shown that mu hat is an unbiased estimator for mu. The next thing you're asked to do is to find the variance. So let's see what we can do. So we want to find the variance of mu hat, which is the variance of this, right? And if you put the variance inside, if you take the variance inside, you get a squared times the variance x bar 1 minus a squared times the variance of x bar 2. Okay, guys. Now, variance of x bar 1 is sigma squared by n1. Okay, and the variance of x bar 2 is sigma squared by n2. All right. Now, I'm going to write, because sigma squared is the common factor, so I'm going to write it like the following. All right. All right. Okay, guys. So this is the variance of mu. Now the question is asking you to minimize this as a function of a. So okay, to minimize this. Okay, because this is the only thing. This is the only thing that involves a, right? Let me call it g of a. You can call it any other name if you like. So let me call this thing g of a times. Okay. Now we want to minimize. We want to minimize g of a with respect to a. Okay. Okay. Now I'm sure all of you know how do you minimize the function. To minimize the function, I'm sure you did one semester of calculus. I'm sure you should know how to minimize the function. To minimize the function, you just you take the derivative of the function and set that to 0, and then you check if the solution is a minimum or maximum. So that's what I'm going to do. So I'm going to take the derivative with respect to a, which is 2a this is the derivative, and I'm going to set this to 0, right? So this implies that 2a times n2 is equal to 1 minus a times n1. And the two will cancel, so this is a n2 equal to 1 minus a times n1. Okay, so this implies that the solution for a is n1 divided by n1 plus n2. Right, now we need to check if the solution is corresponds to a maximum or minimum. And to do that, we need to take the second order derivative. So that's what I'm going to do now. So I'm going to take the second order derivative with respect to a, which is 2 divided by n1 plus 2 divided by n2, all right, which is clearly positive. All right, so hence n a equals to n1 divided by n1 plus n2 minimizes g of a, and because g of a is the only term that is in the variant, that's the only term that's a function of a in the expression for the variance of mu hat. So it also minimizes the variance of mu hat. So this completes question number 2. Are you guys going to this or not? Let me know.
Yeah.
I'm sure all of you.
Yep.
All right. Can you do the next one, please? Question number 3. So let me show you the one. So let me stop screening this and go to share. Okay, this one, share. Okay. Can you do this question, guys? Question 3. Sheet 8. It's this one. You guys okay? All right, let me show you. If you haven't done it yet, but you should, let me show you how to do question 3 now. So this is question number 3, sheet 8. So basically you have x1 xn period. So this is the PDF of the data, and we told that x bar is a possible estimate. X bar is a possible x bar is a possible estimate of delta, right? And the first part of the question is to find the bias of x bar. So part 1 is asking you to find the bias of x bar, which is the expectation of x bar minus delta, right? Which is the expectation of 1/n times the sum of xi minus delta. Yeah. Now I'm going to take the inside, so it's going to be right. This is okay. Excuse me. All right. Now to find the expectation of xi, you got the PDF, so you need to do integration because you're dealing with the continuous. You're dealing with the continuous distribution, right? So you need to find the expectation. You need to do the integration from delta to infinity of x times the PDF, which is this dx, right? This is what you need to do, minus delta. I'm sorry. Okay, now let's see how we can do this. Before that, let me pull out the delta, which is a constant. So you can write this as okay, write this as this minus delta. Okay. All right. Now to do this integration, you need to several of you know working by parts. Some of you don't like parts. I don't know. So I'm gonna use integration by parts. Parts to do this. Okay, so it's gonna be E delta divided by N. So if you apply integration by parts, you get X minus E minus x. Then you take the limits from delta, sorry. You take the limits from delta to infinity. And then you have minus minus, which is a plus, delta to infinity of E of minus x dx, right? And close bracket minus delta. All right, so I applied integration by parts, guys. Okay, I hope you follow me. If you have any question, just talk to me by mic, or you can write on the chat box. Okay, so this becomes E of delta divided by n. Yeah, and you should take the limit at infinity, it will be 0. And the limit at delta will be minus delta E minus delta. And then you have the integration of this, which is not difficult. Delta to infinity minus delta, right? Okay, guys, so this is gonna be, you can simplify this further. So you get E delta divided by n, sum from 1 to n, and this becomes delta E minus delta, and the limit at infinity is once again 0, minus E minus delta. Okay, guys. All right, now taking the delta, the E delta inside, you get 1 over n times the sum of delta plus 1 minus delta. Right, so this is delta plus 1 minus delta, which is equal to 1. All right, so so what we have shown, so we have shown that the bias of x bar is equal to 1, which implies that x bar is the biased estimate estimator of delta. Okay, so that's the question number part 1 of question 3. Okay, now to do part 2. To do part two of question 3, basically is asking you for the limit. If you read the question, guys, you see the question is asking you to find the limit of the bias of x bar as n goes to infinity, which is basically the limit of 1, because remember the bias is 1 as n goes to infinity, which is 1, right? Because obviously 1 does not depend on n, so that is if the limit is just the constant 1. Okay, so that's part 2. Now part 3 is asking you to find a new estimator that is unbiased. Do you have, I'm sure you know, can you find a new estimator that is a function of x bar that is unbiased for delta? It's not difficult, guys. I'm sure you know, some of you know already. All right, so to do this, what you do is this: you set y equal to, say, y equal to x bar minus 1, x bar minus 1 as a new estimator as a new estimator of delta, right?
I want to show you that this new estimator is unbiased because of the following.
Because if you look at the bias of y, right, which is the expectation of y minus delta, right, which is the expectation of x bar minus 1 minus delta, which is equal to the expectation of x bar minus 1 outside minus delta outside. Okay, and we know that from part 1 that the expectation of x bar is delta plus 1, right, and therefore this is equal to 0. So what we have shown is that y is an unbiased estimator of delta. Okay. All right, guys. So that completes question 3.
Yeah.
Are you okay with this or no? Do you have any questions, guys? Hello, guys. Are you okay?
Yeah.
Okay, thank you. All right, now the remaining questions, I mean, the full solutions to all the questions are online. So you'll be able to see all the solutions to all the questions on sheet 8. But I mean, the purpose of the Zoom session is it's not just to do the tutorials, but also if you have, I mean, do you have any other questions you want to ask me about, like to do with the course, for example, like the art coursework or anything? Is there something you want to ask? Let me know.
Yeah. How do I give you the quiz it?
Oh yeah, you can. I mean, everything needs to be submitted like by email. All right, so you can email me the quizzes. The quiz.
Can I take a photograph?
Yeah, yeah.
Do I need to scan?
You can do a photograph and just send it to me as a JPEG file or something. That's fine. Yeah, just email me the quizzes and also the art coursework. The art coursework is due on the 21st of April, so it's a long time now.
Yeah.
You should be able to work on R, because R is a free software. So you can, I think I sent you guys an email on where to download it from. So yeah, so please download it and try to work on it. And if you have questions on R, please email me 24/7 or Zoom me 24/7. So I mean, the purpose of this Zoom session is not just to do the tutorials, but also you can log in anytime. Like I keep my Zoom like next to my bed, so that whenever somebody calls, I answer. So you can, okay, so don't be shy not to, to Zoom me anytime, okay? So anytime you have a question about the course, just try to Zoom me, please, okay?
Okay.
And how's your other courses going? Okay. Are they they're going fine?
Yeah.
All right.
We had our supervision in calculus canceled today because of some issues with the Blackboard collective or whatever it was.
Blackboard collaborator.
Yeah.
Do you find that better than Zoom or no?
Not really. I think Zoom is better.
Oh.
Because the quality is always good. The Blackboard was not that good of a quality. Also, when there are more people in Zoom, there is no problem. While when Blackboard it begins to like it becomes interruptive.
Okay.
And
I mean, yeah. Okay. So. Yeah, I mean the purpose of because this Zoom session is something that I bought myself through my own pocket money, because this is independent of the university. So this is a Zoom session I registered through my own pocket money. So it's So you can join me. I mean, you can join the Zoom any 24/7 and ask me any questions you have. Okay, so that's why I keep the Zoom 24/7, just to, I mean, just for you guys can log in anytime. Okay. So is all of you guys in Manchester? Or I assume most of you have left. Is that right?
Yeah, I'm in Manchester, at least.
Stemo, yeah. Nick, you're in Cape Town, sunny Cape Town, right? I wish I could be there. I miss Cape Town, man. Anyway.
Yeah, it's sunny today as well. It's beautiful.
Yeah. Really.
It's
Okay.
warm as well.
Yeah.
No sweater required. Just t-shirt weather.
It's sunny in Manchester too.
Is it? Manchester is a little bit sunny today. A little bit sunny. Yeah.
That's unusual.
Yeah.
Yesterday I had a question. Can I ask it again now?
Yeah, of course, Stemo. Yeah.
Okay, I'll share my whiteboard. My question was, if we normalize some data, and would like to find some confidence interval. For example, this here. This is the median. Can we just integrate this area here and find the ratio between this whole area and the total area of the picture?
No, I think you got it wrong, Stemo. Okay, can you can I write something? Okay.
Yeah, of course.
Okay, how do I let me see. I'm trying to figure out how to do this. Okay.
You go to share screen and then there is black.
Oh yeah, I know how to do it. Yes.
Okay.
Just a minute. Okay, so if you want a confidence interval, right?
Yeah.
So suppose this is the density of the, say, some distribution. It can be like, for example, the normal distribution. Like, so suppose you want, the confidence interval is basically the interval from this point to this point, so that the area between the 2 points, the area between these 2 points is equal to 1 minus alpha. All right, this area must be 1 minus alpha. So so the area on this end could be, for example, alpha by 2, right? And the area at this end could also be alpha by 2, right?
Yep.
So the whole area must be, as you know, the entire area must be 1. Okay. So the idea for confidence interval is the interval from this between 2 points make up a confidence interval.
Yeah, and how much of the data is within this interval?
Yeah, it is 1 minus alpha %. So if,
but this is the idea.
Yeah, if alpha is, say, 0.05, if alpha is 0.05, then 1 minus alpha will be 0.95. Okay. Which is 95%. So this would be a 95% confidence interval. Okay.
Isn't it the same if we integrate the red area and the whole area and just find the ratio between the red area divided by the whole area?
Yeah. It will be the same. Yeah. Because yeah.
That was my question.
Yeah. Okay. Sorry, I misunderstood. Sorry.
And when we find that ratio, for example, it's 0.95, then alpha is 1 minus what we find.
Yeah, that's right. Yeah.
Makes sense.
All right, man. You have any other questions, Stamo?
No, that's for now.
Okay. All right.
Thank you.
Oh, take care. Okay, guys. Any of the other guys, you have any questions, like general questions? No.